Hello, people who are here. What's up? I do think the embodied chair is a lot better than the Aeron. Honestly, I think the only reason the Aeron is popular is because a lot of .coms used it, and then people bought it because it was the fancy .com chair. Like, I honestly don't think Aerons are very comfortable at all. Um, we have a bunch at the office, but that's because I bought them before I really knew. It was like, I need to get some chairs. I'll get some Aerons because at least I know that they're good enough that other people use them. But like, this is way better, honestly. Will the public beta be in 2020? I don't know. I don't know. Honestly, I kind of don't want the headache right now. So we'll have to see how I feel later. It is a chai tea, but it's not a chai latte. Will I play Horizon Zero Dawn when Sony releases it on PC? I played it on PS4. You want help in testing the compiler? Well, we don't need more help than we have right now. That's the point of having the beta small. Is this a teapot from Czech Republic? Yes, it is. Did the Witness editor have any geometry editing tools? It had limited geometry editing tools, so there was a terrain editor that we only used in the beginning of the game to prototype out stuff. That didn't ship because we wanted hand-authored meshes for terrain in the final game, but that helped us build the world initially. It was like a height field interpolation thing. There was well, the power cables, you would edit those in the editor, and it would spline them. Splines were not, in retrospect, a good way to do that. I would do it with a mass spring system instead if I were to remake that. And then what? Like walls, there's a way to make slabs, right? Like a rectangular solid. And again, that was mostly used for prototyping, or all used for prototyping, and invisible walls. And then there was like a collision, like you could make a sequence of those to make like long invisible walls or whatever. Have I looked at some of the other languages that copied my ideas? Sure. I mean, that's a little bit too facetious. Certainly, those languages have many of their own ideas, but I get really annoyed at this really fast when people ask this kind of question. I mean, if you want to be honest, again, this is the reason why I don't stream new programming language work anymore, is because I'm tired of that. So people can have their own ideas and I can have my own ideas, and you'll just see them when the language is public. Yeah, I shouldn't have responded. Honestly. I mean, you know, like I shouldn't complain too much, because like that's what open information sharing is, right? Other people get to use the information. But I've decided that I don't like the way people are using that information, because they're using it to attempt to undercut the quality part of what I'm doing. Like, people are using it in a rush to market kind of way, where they try to get users for their thing before I release my thing, because I'm working harder on my thing than they're working on their thing. And like, I don't like that, because we've had decades of rush to market. Like, that's the whole idea in the web world, in the modern software world, is you release your thing as quickly as possible and get users and grow. And like, well, on the one hand, that kind of works. On the other hand, that gets you what we have today, where everything is broken all the time and nothing really works and everything is crappy. And our ability even to program is being reduced every day, right? And people are spending their time on more and more increasingly trivial things. And almost nobody actually understands programming anymore. That's what this gets you, right? And so what I'm attempting to do is a push in the other direction. And so when people use my push in the other direction to try to undercut it and keep going in the same direction that's causing disaster, I feel very uneasy about that. And so that is why I have stopped streaming new compiler features. Also, there haven't been that many lately, because I've been going back and working on robustness and simplicity, like trying to make the internals of the compiler as simple as I possibly can, which is very difficult because it's a complicated program. But that campaign has been very successful, but it also just takes time, right? And if people try to, you know, undercut my project because I'm choosing to take time to create quality, why should I help them do that, right? And so that's all. That's all. Do I procrastinate on portions of my projects that I dread doing? A little bit. Sometimes, but then I unprocrastinate. And if I procrastinate on those parts, I definitely just turn around and work on other parts. So it's not like it's that damaging. It's only really damaging if people are waiting on the part in order to be able to do their work. Whenever I make it public, will I share the source also? No, not initially, because again, the number one reason people want source is to fork it and do their own version, right? The number one reason that people want source is that they can disagree with what I'm trying to build and make it the way that they want without having to do all the work from the beginning, and thereby, again, undercut the project by trying to get people to do their version instead. Like, that's, whenever people ask me for source, that's like what they want it for usually, right? Now, there are legitimate reasons to want source, and I couldn't expect a programming language to become popular and broadly adopted unless people have source, right? But initially, no, because I'm tired of, I just don't want to deal with those people. Do you know what I mean? Remember the one guy who asked me what every one of my structs look like? I don't remember that, but yeah. Anyway, I'm trying not to get too bitter about this. Like, really the reason I'm talking about this is because I only realized these things myself. Like, I just stopped wanting to stream for a couple of months, and streaming made me angry and irritable. And I was like, why? Why do I feel that way? Oh, it's because it's being exploited in ways that I don't like. So I just need to figure out ways to stream that don't cause that to happen. That's all. And so today we're going to do some programming streaming. We're going to start by improving some error messages, and then maybe we look for other bugs. And those are things that don't reveal any technical good sauce. I mean, this matters though. So like I sent a message to some friends yesterday or a couple days ago. I was like, oh, I finally figured out something really major and important about the architecture of this compiler that makes it simpler and better and easier to work on and easier to debug. And normally I would present that, but I don't think I'm going to. I don't think I'm going to share that information until years from now because, again, I'm just giving it to people who are trying to undercut the project in some way, right? So that's just, I don't like that, right? I like being open with information, but at the same time, at some point, if you're getting attacked, you have to take basic defense mechanism, or defense posture. Otherwise, you're just asking for it. Now that said, I honestly don't think it's that big of a deal. Like I think this language is much better than the people, the efforts who are, doing this other stuff, of which there are a lot. I'm not talking about any specific person, by the way, because there's at least 5 or 6 like major ones, and then there's other people who are who want me to release the open source so they can do their ones, right? And it's like, it's not that I think that those are actually tactically a major danger to what we're going to do, because it's very hard for languages to get traction in the first place, right? And so the chances of that are not that high. But it just puts me in a bad mood, right? It puts me in a bad mood because I'm working really hard to do things that I think are important, right? And that's not even specifically a particular programming language, right? I'm doing my part in whatever way I can to reverse this decline that's been going on in software in many dimensions, right? And that's very difficult. And I think it's very important to do. And, if people are going to take what I do and use it like a boomerang to just throw it and it curves around in the other direction and increases the decline, that's not helpful. And then all my work that I'm putting in is not going in the direction that I want it to go. So that's why. That's really, and it took me a long time to understand that. But now that I do, I'm like, okay, this is what's making me irritable all the time. So I'm just not going to do it, right? And then we'll see. What event was I planning to unveil the language? That's not, you're getting two things confused. The event that was canceled, we were going to announce a game. And I can't tell you what that is because the people in charge of the event would get annoyed. Could releasing the source also work towards reversing the decline of software quality? You would have to show me an open source project that's high quality. Even one, right? Never mind that the average open source project is terrible quality. But Is there any open source project that is high quality software? I don't know of one. Linux kernel, maybe. That's possible. I don't actually know anything about the Linux kernel. I haven't seen it, and I'm not a kernel person. I do think the philosophy of the Linux kernel is wrong for 2020, and so I would consider it not good along that axis. But whether it's good for the job it is trying to do, I don't know. All right, let's get to some actual programming, because it's very easy. It's very easy to just rant forever about all the things that annoy me in the world. Programming is harder than ranting, surprisingly. We're not going to really do any hard programming right now because, like I said, I'm reserving the hard programming for off-stream. But people can at least see things happen on the compiler this way. How do I define quality of the software? Software that is not buggy, that actually works without the user having to do a lot to make it work, that is understandable when you go read it, that is well documented, that doesn't have a lot of weird corner cases where it doesn't work, and that is reasonably simple for the job that it's trying to do. And this is the number one thing. I mean, sure, all sorts of modern software falls down on quality measures, but the complexity measure, almost everybody fails right now. Like, the thing that happens in the modern day is you add programmers to a project and just your code balloons, right? It's like the inflationary expansion of the universe. Your code just gets bigger and bigger over time, even though it's barely doing much more. And that's a disaster. That is a giant disaster. It's like your country being in debt and the interest payments going up and up over time, except nobody's paying attention to that. And so you won't notice until it's too late. And it's already kind of too late for a lot of things. And the problem with open source is one of the many problems with open source is that's just what happens, is you add more programmers to a project and you get a lot more code, and therefore the project is a disaster, right? Like, all else being equal, lines of code are a liability, and people don't understand this. All right? Lines of code are a liability. Anybody who brags about how many lines of code they have is an idiot and should just go do something else, all right? I mean, they may not be an idiot in the rest of their life, but they're not a good programmer yet, and they should work hard to become a better programmer. Idiot is a little bit strong. But again, I get emotional about these things because the scale of the problem is very bad right now, and people don't... yeah. You know, guys, just don't ask me about other programming languages on the stream. It's just... What can a beginner programmer do to better understand the problem? The thing is, you have to raise your own programming skill, right? Raise your own programming skill, and then you will be able to see all the problems. So to raise your programming skill, you at least have to be better than what the average of what people are doing. So don't pay attention to advice about how people say to solve problems, because that is the average advice, and that will give you average results. You have to attack problems for yourself, think from first principles about what it takes to solve this problem and how to do it well. And that takes time and practice and effort, and it's not easy. But that's what you have to do. All right. Should you just get on programming projects and not focus too much on learning theory? Yes. You should work on hard things. You do want to know about theory a little bit. You want to know about theory enough that when you hit a hard problem that you don't know how to solve, or you're trying to do something and it's a mess, you want to know what to go read or watch or refer to that might help you. Just keep in mind that most, especially when it comes to paradigms of how to program, most of that stuff is garbage. But small elements of it will sometimes be helpful, right? And when things are helpful, that's valuable. All right, so we have this thing where we're just giving a not very good error message. And this error message, so someone has an enum, it's an unsigned type, and they're trying to assign a member of the enum to a negative value. And the compiler is correctly detecting that the value doesn't fit in the enum, but it says too big. It's like assuming because it's an enum that that we went over when in fact it's negative, right? And so I looked at this last night, like really late last night, and I was like, okay, what's going on is there's here's the code. I mean, I don't really want to look at this in Visual Studio because Visual Studio is an abomination, but enum value is too big for its type. The value is blah, the limit is blah. This code is like, this part isn't the old part, but this part, this is some of the original code from the beginning of the compiler where I didn't really know how number types were going to work and all that. So now what I'm wondering about is, first of all, this function, this number survives shift, is only called by enum stuff. This used to be in the parser. It's been moved to the type checking layer. So, well, is it really structured appropriately anymore? Because one thing that I wonder is, like, aren't we going to get a type checking error elsewhere? Like, I want to just comment this out and see if we get a type checking error later in our program, which I think we probably should. And if we get that, then maybe we can move this to that point, right? And then it can just know that this is inside an enum and say this flag stuff. There's a little bit of special case where it's like, we're saying like what the enum was and whatever. So let's just question all of this. We're just going to turn this off and see what happens. Maybe it'll be bad, right? Maybe I'm being presumptuous, but I feel like we should hit this elsewhere. Maybe not, because this function is also maybe the function that, like, I should honestly read the code more carefully, because we might be generating like a cast up here. Let's look a little bit. So, okay, let's get out of this abomination of an editor that can't even scroll in real time. All right, so not that Emacs is a lot better, but it's somewhat better. So if there's an expression, which in this case there is, we get a literal from it. If we couldn't do that, we reject the thing. We say like, it's not the right thing. Okay. We set the substitution on the expression. Question is, where does this get called from? This gets called from infer for a declaration. Okay. And then down here, Actually, no. So I don't think, let's try this, but I actually don't think that this is going to work. I think that this will result in the thing erroneously compiling. Okay. Why did that? Is that the same error message? Yeah. What happened? Oh, because number survives shift is actually, there's two stages of error reporting. One is in here, which is again a structural thing. It's just that this code was old and then I added some more on. So this is only for flag enums, and this does errors for non-flag enums. So we're going to do this. All right. So I think this will erroneously compile correctly. Yeah. So we don't want that either. So since this number survives shift is for type checking just for enums, we're going to first of all make it know that. We're going to hard code it for enums. We're going to put this in there, but we're going to put the two pieces of error checking next to each other. The reason this was after is because maybe this used to be called by other people. So we're going to do this. We're just going to clean it up for a second before we fix the problem. Actually, you know what? Instead of that, let's just flatten it out. Because again, why are we, you know, if nobody else calls this, right, let me make sure. Yep, it's only there. Okay. So we're just going to flatten it out. It's going to be the same code. We're just setting survives to false if we detect an error. And then we're going to do this. Okay, if it didn't survive the conversion and it's a flags, then we do some additional reporting. All right. So there, we just simplified the program a little bit. We can get rid of some of this. So do we have a silent check here? No. So again, this is what happens when you used to have a routine that was more general and now is not, right? It's important to degeneralize things because otherwise your code just turns into mush over time. Because when code gets used generally, you generalize it, which involves adding complexity like those extra if statements and stuff. And then if it then turns out that it's only called by one place, a lot of the time you never remove that added complexity that you added to generalize it. And then that's one way of programs bloating. It's probably not the biggest way, but it's definitely a factor. Okay, so now we're back to this. Except, I'm saying the wrong site. Instead of here, we want this. It's because so that first parameter is the location where you should report the error, and before it was on the actual I guess it was on the whole declaration. Now it's going to be, maybe we should, yeah. Now it's on the actual number, which is probably best. So now we just have to fix this, right? And the thing that's bothering me is I know I have several places in this program where we range check numbers. And I want to maybe use those because some of them are much more serious. So like we have like a cast bounds check, for example. Let's see. Like when we run a cast bounds check, what do we do? Okay. That's not good. I mean, it's fine. It's just, it's not helping us give a better error message. Oh, in the other programming language, in runtime support, when we fail a cast bounds check, we report things, right? And we say the number must be in the following range, which is a more useful thing, right? So we say the number must be in some range, but it was something else, right? Let's just port this back to C++. Here, it's a little bit more convoluted. Because this is a very low-level runtime support function, we don't want to take any dependencies like a printf-like function. So we're literally just writing strings out in multiple pieces so that we don't concatenate them into a buffer, because that takes the fewest dependencies. So it'll get simpler in the C++ version where we don't care. All right, so let's do that. How do I want to hook this in? So instead of saying numeric constant, I mean, I know I have. All right. So we're going to say instead of too big is out of range for this enum. Okay. See, we have two cases, one for signed and one for unsigned, right? However, we're doing it a little bit. We're doing it a little bit wrong. We're just going to totally redo this code. Okay, we're going to leave this aside. And because what we really care about is the enums type, all right? And instead of, we were doing this trick, so what this was about was just shifting the number back and forth and seeing if we get the same number, which is sort of a lazy way to handle all the cases. But like, we want to give a good error message. So we don't want to be lazy about that. Like this was just a way, do an operation and just say if the result is right or not, right? But we're just going to take a different tack where we get particular about it, right? So So here, again, we're doing a shift thing, but oh, I guess it's almost the same, honestly. All right. So we're just going to copy this. All right. So, but we're not necessarily, the difference is in this function, we already know that we failed, and we're only calling this to report the fail. Because the actual test for failing was something more like this one, right? Because you want to emit something into the code that's inexpensive. But here, we don't exactly care about that. Okay. So we're going to do this. We're going to say, is the enum signed? Right? If the enum is signed, then we want to report things as signed, right? Okay. Now the problem is really annoying now, because, oh, maybe it's not. Maybe it's not. Okay, this is good. So we had this thing. This thing down here is about if someone writes a number as hex, for an unsigned enum, you don't really want to interpret it as signed. And right now, I mean, this is a thing that's a little bit messy in the lexer. Like, what we should do is record the fact of whether or not you put a minus sign, but we don't exactly do that. In part, though, because that itself is a little bit complicated, because it might not have been a lexical minus. It might have been like a minus that was constant folded into the number. I don't know. Like that's something that we should refactor and make more clear. For now, we're not going to change the policy on this. We're doing an orthogonal thing. So we're saying here's the high value, here's the low value, right? Let's just fix this part. U64 high value is how does this work? 1 ULL? Something like that. U64 low value is 0, and then we're just going to do that. All right. And then we're going to do I guess, see, we do, actually what I said about the minus sign might not be totally true. Might not be totally true. Okay, so we just need to do all the cases here. So if it's a sign type, we get the high value, we get the low value. We already have a signed thing. This is where it gets annoying. Okay, so let me refresh my memory, because this might be the time when we change some of this stuff. We have literal flags that are different from the type flags. Okay. What are these? Minus sign. Okay, so we do flag it as a minus sign. The question that I have is, when we constant fold things, do we set this? Or, oh, see, damn it, dude. I almost want to do this comparison in 128 bits. So the problem is we have a combinatoric thing. Okay. There's this thing in this language where you don't suffix numbers at all, like numeric constants. This is good because I didn't think about this back when this code that we're editing is so old that I didn't think about this stuff. Maybe we should just solve it part at a time. But so like numeric constants have a special type that enable them to be autocast to other things, which is why you don't have to suffix anything in this language, right? You don't have to suffix your integers to say what type they are. That, we might be dealing with that. Or okay, we do. Or we might be dealing with a literal that came from somewhere else, like, you know, through runtime execution or something. But I guess the policy is that it does always have to be treated as a literal. Which means there's something we'll have to do later. But maybe I don't have to worry about that now. I'm making a note for something to think about later that once again, we probably won't stream. Okay, so here we toggle minus sign when we negate a literal due to a unary operation. This is part of constant folding. This should actually be in const expert, right? Like who, why is it here? Oh, because the parser also, yeah, whatever. We could factor that later. Anyway, so this is actually okay. So we do have an explicit minus sign. So we're going to say, what was it called? Literal numeric minus sign? Yeah. If it's got a minus sign, otherwise, right? And this is where it just gets frickin' annoying, right? Because unless you want to go up to a bigger word size, which I don't really want to, because then you get like more operating system dependent and stuff. Like you're trying to compare. In this case, it's easy because it's the same type. In this case, it's not easy. All right. So if it's got a minus sign, then we've got our S64 is, what's it called? Integer value. Okay. We store this as an S64 all the time. I'm super sloppy with my literals right now. Like we don't even union this. There's all this extra stuff. It's like, whatever. If this is unsigned, it's just stored as S64 and then you're supposed to cast it, right? Which will throw the C++ language lawyers into a tizzy, but come on, guys, it's fine. So we say literal integer value, right? Right? And then here, we want to think about this. Like later when we make this a union and don't store all these things differently, we would probably have an integer value S64 or an integer value U64. In fact, that's a thing to think about. Like it might be time to do that. But, you know, this is the kind of thing that we just don't care about, and still somehow everyone else's compiler is way slower. Like, it's because programmers generally don't focus on the things that actually make you fast or that actually make you slow. They focus on their weird religious belief of what makes you fast or slow, which is wrong. Okay. So if the literal is negative, then we just do a straightforward test here. We say we're fine, else we report an error here. And we're going to give ourselves full context to make these error messages different. We're going to set this, and we're going to say numeric constant is out of range for this enum. The enum is declared as type %s. So the value must be in the range but the value is whatever. Okay, so we're going to say type name, which we don't have yet, low value, high value, right? Okay. Great. The reason this is such a pain in the ass is we're going to have 4 cases, right? We're going to do 2 cases here, and then down here we have 2 cases. Okay. I mean, actually, this is case number 1. Case number 2 is going to be here, and then we're going to have 2 cases way down there. Right, okay. So type name, I think I have type to string, right? Type to string, taking a type definition, yeah. So we do that. Okay. We could test that right now, but our code won't even parse yet because I've got all this junk down here. So we're not going to worry about it. Okay. So here we have a U64, right? And we cast so here's the thing is we know that high value is not negative, so we cast to U64 here. I'm going to do it explicitly for clarity. All right. So here we only have to check. Oh, you know what? Well, no, because we're going to use it again. Here we only have to check against the high value. We know it's not less than the low value. We know it's not less than low value because low value is negative, but our value is unsigned. So we only need to test high value. test against high value. Right? Makes sense. Okay. So if value is greater than high value U64, we again do this stuff. These are LLU, LLU. Now again, we might think about writing these in hex in some cases to make better error messages. Who knows? We might want to consider that. And like honestly, you know what? Okay, before we keep going, we're just going to comment out the rest of this. Well, let's just finish this. This is auto. Let's go interp report info. Here is the enums type declaration. We'll do this down at the bottom, right? Like after all our cases are done, we'll do this. If we didn't survive, we'll also tell them, well, because it might be like a 7-page enum, right? And they want that in the error message. Type to string, not visible from here, because we're in C++. Oh, well, no, it is visible. I spoke too soon. It's just a, all right. Survived. Oh, survives. All right. What I want to know is, ignoring all this, don't we already do like x is a U8, x is -5. Is our error message crappy for this? Like what? Like, why don't I just use that? Why am I doing all this, right? Okay, this is not good. This is not, we want, okay. We want to clean this up. As well. Oh, which does not fit into. See, you know, I start streaming something and then it gets more and more. Okay, this is that thing. We're gonna clean this up later. We're gonna say clean up report type error info to use enum code. Okay, so we're going to write this code for enums right now. We're going to be very explicit. Instead of just saying which does not fit into this type, we're going to say what the range of valid values is. Maybe we'll even print it in hex sometimes, who knows. And then after that's done, we will refactor that out and use it here. And we probably don't have time to do it on this stream because I have to end this stream because I have a call, not soon, but like in an hour and 10 minutes. So we probably won't get all the way to that. And that might not be the priority. The priority might be Yeah. So right now we don't even correctly detect this case right now because not all our cases are in. So let's go back to that. Okay. So that's the case of an unsigned enum, and we don't even go there. We're only doing signed, right? So we want an else. These are our first two cases. Let's test these first two cases before. I've just noticed, when I stream like this, I change my mind very rapidly about what I'm going to do at any given time. And I hope it doesn't drive people crazy, but it's how I program. Oh, whoops. Let's make this test 2. Okay. Well, this is incorrect. Good thing we tested it. Low value is not correct. Why not? And our value is also not correct. What am I doing? Okay, this is just when you mess up the print function. The enum is declared as type S16, that's right. But our low value and then our actual value, what did I do? Type name, low, okay. First of all, we didn't pass the value. Second of all, maybe low value is actually correct and was just screwed up. I don't think so. I think we might have a problem here. Oh, it's printing it as unsigned for some reason. Is LLD... Is LLD unsigned? I thought LLD is signed. Somebody who does C++ printf all the time, or C printf, this is supposed to be signed, right? Let's print out we're not even in this one. We're in this one down here, but we'll put it in both. %LLX, right? Low value, like. Yeah, like it's got, does it have enough Fs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. LLD is signed. So why is it printing out my LLD, which is all Fs, as unsigned? Oh, it's using LLU in the low, right, okay. Good. Right, I got confused, right? This is LLD, right? But the value is LLU. Yes, okay, thank you. Thank you, all right. I mean, I would have got that myself, but it's always good to have a positive interaction with the chat. All right, so there we go. This is actually wrong. Why are we minus 32767? What kind of garbage is that? What? Is it really just not high value? I thought 2's complement was you flip the bits and add 1 to negate. Right? FFFFFFFF is -1. You flip all the bits to get 0, you add 1, and that's the negative, right? 0, to negate 0, you flip all the... bits. What is going on? Oh, because we don't, the low value isn't the negative of the high value. Right, duh. So this is like, okay, let's fix this in runtime support. Sometimes I'm just stupid. Yeah, like, yes, that's how you negate a 2's complement number. But no, the low value is not the negative of the high value. I was just confused when I typed that. All right. So now we have the right values. And we fixed, let's put that in our change log, fixed incorrect reporting of low value in array bounds check fail in runtime support. And this one's more major, so we're going to say improved error reporting for enum values that are out of range. We're going to put that up because that's like not exactly a bug fix. It's just better error messages. All right, so we do all this. Okay, so let's now go to our test. See, it's good to test your code. If you don't test your code, it is broken. So we're going to make this a U16. Actually, okay, let's go S16 and like minus 70,000, right? So that should work. Okay, great. So U16, now it's not going to do anything, right? Yeah. Okay, so we need to make this work. And again, the literal could be a negative literal or not. Okay. If it's a negative literal, we know the enum's range starts at 0. So here we're going to like do this. Well, let's copy what we did down here. Not that that is guaranteed to be right. Where was it? I'm looking at too many frickin' things. Okay, let's get rid of this. This is very old. This is what was from preload, and yeah, we were just doing this. Oh, I typed the ULL already, and then I just moved it. Okay. So we're doing high value, low value. This is wrong, actually. Oh yeah, this is wrong. Oh no, it's not, right? This is, okay. This is C++ UB right here, because bits could be 64, right? So this is why you actually want to define these things better. Doesn't matter. All right, if bits is 64, else, yeah. Right? I hope that's enough Fs. Press F to pay respects 16 times. So now we also should probably do that here. Like, I guess I wasn't at my most, because we don't yet, we're going to have a more stringent definition of left shift later, but we don't right now. This isn't UB, in this programming language. It is implementation defined behavior right now, and it probably won't be later. We're generating results that will vary on different machines unless we check. So let's check. All right, so if high value, or if, same thing, if bits is 64, right, else all right. Yeah. Okay. So let's go back to our thing that we're working on. All right, so we have a lot of F's to pay respects. We get our high value, right? I can't say UB except in sarcasm quotes. I'm sorry. Okay. So we've got a low value, which is always 0. We've got a high value, which is an unsigned number, right? We pasted all these comments. We'll keep the hex comment. So these are both unsigned. So if the value is greater than high value, so value must be in the range whatever, but the value is LLU, right? It's fine. You know, so you might want to factor this out to down here because we could say the same thing. You probably want to say the same thing string-wise, mostly between these cases so that people could like search for the error on the internet. However, you can't really do that because the types of these are different in the two cases, and like the amount you would have to have like 4 variables up here, and the amount of work you would do to like factor this out would be annoying enough that it just don't bother, right? Okay, so if the literal is negative, then okay, here we need this. And then here, well, if value is less than 0, we'll give a slightly different error message in this case, I guess. We'll see how that feels. Okay, so now what do we do here? So we know if it's not less than 0, we know the high we know the value signed bit is not set, so we can correctly cast to U64, right? And then, so if value U64 is greater than high value, whatever, right? So if value is less than 0, numeric constant, so the value should we bother? No, you know what? Let's not bother. Okay, let's do this. We only use value 64 if we know the signed bit is not set. So this is fine. All right. So then we just give our same message. Okay, what is all this down here? This is all stuff that we copy pasted, right? So if the literal is negative, if the value is negative, or the U64 cast of the value is greater than high value. Okay, this stuff is up here. Blah, 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 blah. All right. So everybody, I mean, we may have to fix a couple bugs, but like this is the amount of code it takes to do some simple dippy thing like see if a number is the right size. It kind of makes you question whether having signed and unsigned types is the correct complication for your programming language. Casey has some opinions about that. He says you shouldn't really do that. I'm not sure if I agree or disagree, but for now we do have signed and unsigned types, and well, this is part of dealing with that, is like, oh my God. The positive thing is we're going to be able to factor this out and use this in the other place later. Not yet, but later. So the enum is declared as type U32. So the value must be in the range, whatever. Here's the enum's type declaration. There we go. You know what? Let's, the U32 is not highlit. We'll fix that after we make sure all the bugs. So the value must be in the range of this. That looks right to me, but the value is -1, right? What did I just edit down here? Oh, this stuff. And then we're going to want to look at this flags stuff because I don't even know what this is doing, and like, yeah, okay. So we're going to go back to our test program, and we're going to say, what if it's positive 70,000? Oh, because that's the wrong one. It's this one. What if it's positive 700? Why not? Why not 700,000? It's fine. All right, so that's all great. The unsigned case is mostly kind of easier. Anyway, this is, you know, even for a beginning programmer, the reason we want to print this range is, say you're a beginning programmer and you don't even totally know what U16 means, and you copied some stuff off Stack Overflow, and then you tried to add a value. And this is like, look, it's telling you what U16 means here. That said, we should probably also add, please do not copy and paste code from Stack Overflow here onto the error message. But we won't do that because they might have used experts exchange or something else. So we don't want to make that assumption. Okay. I'm gonna warm up some tea water. Are there any questions about what we have just done so far? What's Casey's opinion on signed, unsigned? You should ask him, because if I try to explain it, it's actually a detailed topic. You should ask him about it. All right, on topic questions about what's happening here. By the way, you know, I'm saying this is how much code it takes to tell if an integer is the right size. This is short for modern programming. Like, dude, if this was inside LLVM, it would be like 17 pages and in 5 files. All right. So like, we're actually doing pretty good here. What if literal is bigger than max264? It cannot be. There's no such thing as a literal in this language that is bigger than 64 bits. A little overview of what's happening for people joining. We don't do that. Sorry. If you repeat yourself every 5 minutes in the stream, you're like a radio station announcing that you just never get anything done. All right. What is the advantage of not having unsigned types? Again, ask Casey. That's not my viewpoint necessarily. I've actually seen LLVM source. I've certainly seen, I looked in LLVM source a little bit, but I've definitely seen what you have to do to use LLVM. Oh my God. Would this handle minus 70,000? It should. Well, it would have to be something like 7,000 to fit on a U16, right? Okay. The problem with this is that minus 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 is a token. Let's try this. All right. It's positive. Wait. Yeah. So that's correct. If we wanted 3 to make sure that it was negative, there we go. The value is minus 7,000. It knows. It knows. It knows, man. There's a comment about negative signs in front of hexaliterals. How are you handling that case? Well, that is just the number. Like if you put a negative in front of a hexaliteral, it's just a minus in front of whatever integer that is, right? So then the question is just, should that affect how we do error reporting? Like that's the part that I'm a little bit not sure on. But it doesn't matter. So that used to matter for correctness because we were using number flag hex to make decisions about whether to interpret it as a signed or unsigned number. We are not doing that in the new version because it's not necessary. Like that was written before we made decisions about how the type system works fundamentally for numbers, and it's not necessary to do that now. Can you ask what benefit there would be in leaving something like left shift up to the implementation to define? So the point is CPUs do different things when you left shift by more than the word size or equal to the word size. So for example, a very concrete example, today, x64 CPUs and ARM CPUs will do something different if you shift a number by the number of bits equal to its size. You will get a different result on both of those platforms. That's kind of stupid and unfortunate, but it is what it is. Now, if you wanted a consistent result on both platforms at a language level, then every time you output a variable shift operation, you could do a runtime check on the platform that does the thing that you don't want. I will claim that you never want to get the original value back. Like you always want to essentially mod the shift amount by the word size and shift. No, that's not even true. You just want it to be anything by greater than or equal to the word size is the same as shifting all the way. So it would be like either 0 or like all ones if you're sign extend shifting to the right, right? So in order to make sure that that's the result you get, you would put a runtime check every time you generate the code for that operation on the CPU that does the wrong thing, and then the CPU that does the right thing, it's always fast. And honestly, I don't remember which is which right now. That's fine. And that would have been back in the 70s when C was being made. That would have been considered a very expensive thing to do. Today, it's not that expensive because you don't variable shift that much. And I would say it's better to know that it's correct and have simpler code. And then for people who don't want that checking, give them an option. So what we would do is say variable shift by default performs that check. And then there's no undefined behavior. There's no implementation defined behavior. It's completely consistent everywhere. However, if you want, you have the option to use the implementation defined shift, right? And then you're taking the safety off the gun, and you better know what you're doing. So that is how you would do this correctly in the year 2020. I mentioned speed was important for the preload cast fail. You didn't uninitialize high value. No, it's not important for reporting. That function that we were editing just reports the fail. Speed of that is not important at all because your program is exiting at that point. The place where speed is important is the actual check, which you didn't see there because that check gets output inline whenever we generate machine language for a particular cast. Does the minus minus a million get cleaned up during parsing? Yes, it does. That was the thing. If you saw the thing where we XOR literal numeric minus sign, that's what does that. And we saw that a second ago, so that's an old question. How do you handle constant operations? Are they evaluated with the compile time execution system or optimized out by LLVM or something? Neither. Constant operations are, I hope I'm not oversteeping my tea. Constant operations are performed, they're folded by the front end before we even do the rest of type checking. You don't want to rely on LLVM for that because that's too late in the back end. And we also don't rely on LLVM for anything except LLVM. And your front end needs to know this because it matters. Like, there are certain places where you can only use a value that's known at compile time. For example, if you're declaring a constant value, right, then the thing that you declare that name to be bound to has to be known at compile time. And if you're waiting until way later in the pipeline of the compiler to know what that is, then you're not able to really do anything with it. So that's bad. So there's just a whole thing that says, hey, are we doing a binary operation on known operands? Well, let's just run it let's just perform that at compile time. Do we use compile time execution for that? No, because compile time execution is way too expensive for something like that you're going to be doing all the time. So there's just inline code in the compiler that just says, like, look, integer plus integer. We know what that is. Let's do it, etc. Or like casting an integer, casting a constant integer of one type to another type. We know how to do that. Let's just do it, right? All right. Does that mean you have to do constant propagation before LLVM? I mean, it depends on what you mean by constant propagation. In the back end, you generally would have a mechanism for constant propagation. Because just as you optimize code, you sometimes realize, oh, in this particular, we inlined something, and in this particular case, this branch doesn't ever get used. And that means that the value of this thing is always 7. And so we could just use 7, right? So you want that in your back end. But you also want it in the front end because A, your language semantics depend on it in some cases. And B, you want to give guarantees to the programmer, right? Like if you just find some constant like, some constant like these, where you all caps them traditionally in C, and then you add 1 to it somewhere, which happens all the time. You want to know as the programmer that is 100% guaranteed to be a constant, and that anything else that cares about that being a constant can do that, right? And that cannot happen if you rely on compiler optimizations to do that, because they'll get confused about something and won't do it in some cases. And also, like I said, that's too late in the compiler to know those things. And so it has to be a separate mechanism. Okay. We have about half an hour left in the stream. I will do another stream probably later this evening where we do some documenting, because that's the other thing I want to do before. I want to put out a beta tonight before the end of the night to our valuable beta users. And I've been going down the bug list, and this was one of the bugs. This program print one is worse. I'm going to work on this one off stream. And then this one's kind of trivial and goofy, so we'll work on this one. This is just an error message that's not good. Let me check in what we have. Do we have any no check-ins? Yes. Oh, that's from the other thing that I was working on. We just won't check in that file. Boop. Okay. Improve error checking for enums. Oh, you know what? Let's look at enum flags. Like, this extra reporting for enum flags, I'm not even sure if it's necessary or helpful. So if we do this, and I say that's 70,000, like what even happens right now? We get the same error. We get this, oh, the enum type declaration, right? Enum value is too big for its type. Okay, because it's flags, we're reporting. See, this is very redundant now. You know what? So let's delete this part. And we'll print things as hex, but only in the case when they're unsigned. Because again, if you somehow do like a negative flags value, that's obnoxious. All right. So we're going to say if it's flags, we're just going to do this. You know what? We're just going to do this. All right. So and if the value doesn't have a minus sign, because if you made it negative and it's in an enum flags, you sure are doing something weird. Okay, so if it's flags, we use hex. And in two of these cases, we're going to use, okay. So if use hex, else, right? And the only difference is we're just going to put LLX, LLX, and LLX, all right? And then down here again, you know, we could like, since this is an error report and it doesn't have to be fast, we could just make the string for the range separately and then print into this giant thing and get the type name and all that. But then we would also have to make the value string. It's just enough annoyance to not be worth it, even though we're duplicating this string a bunch of times, which is bad in its own way. But you know, if we just generated a string for this and a string for this, then, you know what? let's do that, because at this point there's enough paste that this is just bad. This is just bad. We're going to do that. But not yet. First, we're going to make sure this works. And then we're going to have to test all this again. All right. Oh, let's get rid of, let's delete this part. So that's good because we added a bunch of code, but we deleted a bunch of code. The number of lines has still gone up, but we got use out of it, right? We're getting a better error report, and the number of lines didn't go up that much. Oh, we didn't set. Whoops, I deleted too much. Right, remember when I factored this into here, I thought I was being fancy. All right. All right. So, bam. Here's the enums type declaration. Numeric constant is out of range. The value is 11170. I mean, let's put the OX in front of those, because 11170 is like, you know, you could be saying that's decimal and say, but that's less than 65536. What's your problem? All right. Especially if we start using this routine in other contexts. All right. So the value must be in the range, well, let's not say 0x0. Oh, God. All right. You know what? This is going to clean up in a minute. This is going to be fine. We're going to fix this with a refactor. I'm going to commit. Enum flags improvement. Okay, so now we're going to do this. We're going to say this whole thing, if it didn't survive, we're going to do this. And we're not even going to use survives anymore. We're going to say if, we're going to check these strings to see if they're null. We're going to have a thing called range string. If range string is not null, assert value string is not null. And it must be in the range there. The value is that, right? And so range string, value string. All right. We're going to set those to null up here. Great. So now instead of this stuff, oh, and this part, this type name part is down here as well. So we're going to get rid of that. 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 And then we're going to get rid of survives. Okay, so and then the bonus of this is when we internationalize the compiler, of course, you want to have different translations for this string. And if you have to have like 17 different ones, that's a giant pain in the butt. All right. I just have to make sure that I do this correctly. All right. right? And then value string equals, oh, it's OX. I almost regressioned, except oh, this is the wrong. I messed up use hex, guys. We only want to use hex when the enum is unsigned, not when the value is unsigned. So this is stupid. This is wrong. Because I was looking at this, I'm like, what is going on? All right. Range string is mprintf %ld, low value, high value. Value string is mprintf. Right? Great. Great. Okay. And actually, I don't think we want to write this in hex. Like, if the literal's in hex, it doesn't matter because we want the decimal to compare to the decimal, you know, so that's fine. All right. See, this is becoming more understandable, I guess, as long as you understand that this means we're going to report an error. All right. So down here, if use hex something else something, okay? It's going to be LLU for the range, or no, LLX, and 0, actually 0, comma LLX, right? Because we're unsigned. Somebody could do assigned enum flags of a signed type. That is kind of goofy. Maybe we should disallow that. Let me write down what happens. What do we do? Right now, we just won't report in hex. It's fine. It's legal to do. We just won't report it in hex, which is fine. We're only going to do hex for unsigned things. And this is LLU. Let's get rid of low value. All right. So we're in hex or we're not in hex, and we need value string equals mprintf value. See, this is weird. I guess we're gonna do it, and we'll print all the F's. Let's put both. We'll say, here's your hex number with a lot of F's. See? This is in both cases. Okay, so if value is less than 0, else we'll put it there. Right? Okay. Okay. Now, if value is greater than high value, simpler case, So the reason you might look at this and say, why don't you factor this out with these? And the reason is because doing this print incurs a substantial performance cost because we're allocating memory and writing strings into it and stuff. And you don't want to do that if you're not actually going to report an error because things are fine, right? That's why, even though you might see things that we could factor out, that's why we are not factoring them out, because they cost cache money, aka CPU cycles. Okay. And then oh my God, I hope I got this right. All right. So it's a little bit cleaner up here, a little bit dirtier down here because of the use hex. It's fine. I'm getting hungry. Okay. That is... I kept saying %LLX without the OX. Come on, bro. Get with the program. Why do I not learn? If we do not learn from history, we are doomed to repeat it. All right. OX 11170. Unum is declared as type U16. Okay. Let's make it fit in U16. It compiles. Let's put a minus. 7,000 DKP minus. All right. So the value is blah minus 7,000. That's because it's a flags, right? Which, I mean, it's flags, so we're just saying we want hex. That's fine. What if it's assigned flags? Why would you do that? I don't know. Minus 7,000 does fit into S16, right? Minus 70,000 doesn't. And so now, even though it's flags, we're resorting to integer reporting because signed is like, ugh, I don't know. If we want to change this policy, we could think about it later. Okay, so now going back to, we got to go test all our regular enum stuff because we just changed a bunch. So like, okay, unsigned enum, unsigned number. All right, now does it fit? Yes. What if it's signed? No. Oof. Woof. I put an OX where one didn't belong. See? What a mistake. OX %LLU. There it is. Why did I do that? Because I was stupid. This is why you test your cases. This is why you don't be like an open source guy and you actually make sure everything works before you fucking ship it to 300 million people in the world. All right? If there was like a Goofus and Gallant book, Goofus would be the open source programmer, and then the average industry programmer would be Garoofus because he's also Goofus. And Gallant would like not even be a programmer, honestly. Okay, so signed, that should fit. That should not fit. Whoops. This should also not fit. So I think we're pretty good. Goofus and Gallant. Look, I read, was that from Highlights magazine? I read Highlights magazine when I was a kid. Highlights magazine is good times, I think, right? Do people know what we're talking about, right? Let's bring it up. Wikipedia has a page. What? I don't want to drag that. I'm just trying to pull it. There we go. Here we go. What? Zoom in. Okay, Wikipedia is not good at media anymore. How do I... Okay, we're not going to go to... They probably just grabbed... So, you know, these are all comics about, like, how to behave. Oh, this is a parody, clearly. I mean, you'll probably just find people riffing off of these and not actual scans. Anyway. Yeah, Goofus and Gallant taught ethics, which is something we could use a lot more of today again, because we've decided that that was bad for some reason, except we haven't. Now we teach people ethics, but they're like weird, screwed up ethics, and we ignore the real ethics. So that's a giant crazy thing. Do I have any idea how many lines of code were written for the witness? I honestly don't remember. It was at least 200,000. Something like that. Because morality is binary. Well, that's a, you know, I mean, you're teaching this to 8-year-olds or whatever, right? So I think it's fine to have binary morality for a little while. I think you might not need the UB thing because no literal will overflow U64 max. No, okay, let's look at that again. It is necessary because this bits here is 64. You can't shift one left 64 in C++. That is UB if it's in a 64-bit number, right? And the reason is because on some processors, that will shift the one off and you'll get 0 back, which is actually what we would want. On other processors, it'll fail and just give you your 1 back, all right? So that's UB, but the fact that it's UB instead of implementation-defined behavior means that if your compiler sees this, it can go launch the nukes. And you don't want to end civilization by letting your compiler launch the nukes, so you have to avoid this. Will there be a concept of UB in our programming language? No, there will not be. There is no UB in our language at all, whatsoever. If you use %hash LLX to your hex prints, it will add the OX prefix for you unless the value is 0, in which case it will just print 0. Okay, that's cool. I mean, we don't need it right now because this value is never going to be, oh, I guess for this. Okay, if the actual value you passed in was 0, except if value is actually 0, none of these errors, 0 is in range of everything. So we're not going to worry about it. That's good to know, though. How can you avoid UB when using LLVM? If LLVM thinks something is UB, then it is wrong. And it is our job to eradicate LLVM eventually under those conditions, right? Unless it gives, like if we're able to explain to LLVM why something isn't UB, like by casting it in certain ways or something, then we do that, right? And then we just complain because it's a giant pain in the ass and making us do all this unnecessary work. If we are unable to explain to LLVM why something is not UB, then that just means we have to abandon LLVM eventually. Or let that backend be used only in a very provisional fashion. It would have to be, use this at your own risk because you know, it's only there to give us support for this platform that we don't have a backend for yet. But you're using it at your own risk because it might launch the nukes, right? Okay, so we have done some stuff here. That's great. Let's actually comment before we check this in. If we set range string, that is an indication that the number will not cast correctly, and we will report an error. And if range string is set, value string must also be set. Okay, see, we were good. We were a good person. We were gallant right there. Gallant comments is things that will not be obvious to people when they look at the code. All right. Improve enum error. Reporting some more. Okay, everybody. Any final questions that are on topic? I have to end the stream. I have a call at 2. We'll do a stream later tonight where we document some stuff or something. Is there a data type called byte, or is there something like unsigned character? There's U8, which is unsigned 8 bits. You're skeptical about my claim of no UB. That's why C allows for UBs. It's not that they were too dumb to just block them. I already explained, were you on the stream when I explained the thing about left shift? Because that applies to everything. The thing that I said about left shift applies to everything. And that's fine because the speed hit that you take is the speed hit that you take is literally orders of magnitude less than it was in 1970 relative to the rest of your program. Like relative, for example, to the memory wall. You give programmers the option to do the fast thing. That's just how it should work. Like, anyone who thinks that that is not the right approach is drastically underestimating the loss of productivity and loss of morale and loss of quality of life that's involved with not really knowing what your programming language is going to do with your primitive types all the time. Like the fact that basic integer operations in C are UB is insane. Or at least for C it was fine for the time, but in C++ it's insane. It is straight up crap, right? The fact that you're going to pile all this stuff onto your programming language and basic use of the plus sign or bit shifting is UB in some cases. That is garbage. That is beyond garbage. That is... You're just bad at your job if you're making C++ 20 and integer operations are still UB. All right? Garbage, garbage. You are so far beyond Goofus. You are too Goofus as Goofus is too gallant in that case. That's all that I have to say about that. Now the question is, okay, so you get rid of UB for all those basic things. Is there going to come up some case where UB happens, right? I don't think so. You know, there are some other cases like, well, what happens if somebody leaves a variable uninitialized, right? Isn't that UB? No, it is implementation defined behavior where there's an unpredictable value in that slot. You just define it better, right? You say, well, what's in this integer? We don't know. We know it's still an integer. We just don't know what the value is, right? That's not UB. So you just keep doing that. Will there come some really, really hard case that we're unable to solve? I don't think so. Because I understand what computers are and how they work, but we'll see. forward progress is undecidable, and the opposite of that is UB. Yes, but we don't have a programming language primitive that says halting problem solved (A:(B). That is not a construct in our programming language, and so we don't have a UB problem there. You have somewhat defined behaviors. You can live with that. Yeah, it's not about, I would say somewhat defined is not the right term. It's what defines the behavior. The behavior is always defined. Sometimes, okay, the behavior is defined by your CPU. So, in fact, instead of calling that system-defined behavior, we should call that CPU-defined behavior or processor-defined behavior. The compiler is not allowed to assume, unless it knows what the specific processor is doing, which it actually does, right? It's not allowed to assume that that's not defined in some way. The processor defines it. You either know what processor you're running on and what that definition is for that processor, in which case, fine, you can do some things. Or you're living under a veil of ignorance, which is also fine as long as you understand that you're living under a veil of ignorance, right? This UB thing is just so amateur hour. I'm so tired of it, and I have no tolerance for people who put up with it. It's really, I mean, I sound like Dijkstra right now, but like, Jesus, guys, you're ruining everything. All right, that's the end of the stream. We'll come back with another stream later on. I hope you enjoyed this last-minute rant. Thank you, everybody, for coming by. I'll see you later. Factorio developer is streaming. Maybe we'll raid. Let me see. Science and technology. Whose stream is it? I see like a naked guy. What? I don't. Are sending 91. Oh, it's not on science technology. Dev work, prototype explorer, GUI. All right, looks reasonable. We'll raid that. Thanks everybody for coming by. Bam.